Hey there, welcome to another edition of quantitative reasoning stuff, if you will. This is section 1B, propositions and truth values. So we've got some definitions to talk about first. A proposition is a statement or a sentence that makes a claim. That claim can be either true or false. It's supposed to have this complete sentence structure. It has to be a complete sentence, right? And the possibilities are you can be true or you can be false. And so we use a truth table to sometimes represent all the different possibilities for the propositions we're being considered. So if you think about it, for an example, if I say today is Monday, well, that's a true statement once a week, and it's a false statement the other 6 days of the week, but it's always one or the other. And if you're in the same time zone, it's never, both at the same time, and it's never neither one. It's always true or false, one or the other. And so that makes it a proposition. It's a claim. Today is Monday. And so depending on when you're watching this video, that may be a true statement or it might be a false statement, but it is definitely one or the other. And so that's what a proposition is. Okay? So when you get done with propositions, just get the understanding of propositions, then what happens is a proposition is usually kind of a single, simple idea. And then we put them together, we put simple ideas together, single ideas together, in order to form more complex thoughts. Okay? So in order to do that, what we do is we take these simple statements and then we join them with what are known as connectives. And a connective is something that has a little bit more action to it or connection to it, if you will. And negation is the first one of those. So negation of a proposition is a second proposition that makes the opposite claim. So if P, for example, is today is Monday, then what would the proposition negated be? What is the not P? Not P then says what? Today is not Monday. And obviously, one of these statements is true and the other statement is false depending on the day of the week. So when it's Monday, when today is Monday, then not P is a false statement. But if today is not Monday, right, if it's Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday, then today is not Monday is a true statement. And so this is true for all negations, that if you negate a truth statement, if the truth statement was originally true, the negation is false. If the truth statement was originally false, the negation is true. This is the idea of a truth table right here. How many different possibilities are there for P? There's only two, right? P is either true or it's false, one or the other, because it's a statement, and therefore not P is the opposite. Okay? Now, one of the reasons we do these truth tables is because sometimes words can be very confusing. And so you have to be careful of what is being said. Find the negation of the proposition Amanda is the fastest runner on the team. Write the negation of that, okay? So that means simply Amanda is not the fastest runner on the team. You can't jump to another conclusion and say, okay, Amanda is the slowest runner. The opposite of the fastest is not the slowest, right? It just means if you're not the fastest, that means you could be the second fastest or the third fastest. It could be that you're the slowest, but it doesn't have to mean that. And so if Amanda was the fastest runner, then this statement would be true and this statement would be false. If she is not the fastest runner on the team, then this statement would be true and this statement would be false. That's just the way it works. Now, if you negate things twice, not P, well, just like a double negative in mathematics, two negatives make a positive. Well, not P also makes a positive. All right, and we try not to speak that way, but occasionally that happens. So here's an example of that. At Oak Ridge National Laboratory, they did a study on workers there because of low-level radiation and cancer. And so according to this researcher, he was quoted to say, "My opinion is that it's unlikely that there is no association." What? What exactly are you saying here? Well, My opinion is that it's unlikely, a negative, that there is no association, a second negative. So because they're both negatives, that's like a double negation. And so the same words, the same wording would be, it's likely that there is an association between low-level radiation and cancer. And so when you say unlikely not, then it likely is. And so it's kind of a, I don't know what this guy was doing necessarily, but it sounds to me like he was trying to kind of hide the fact. He didn't want to say that there is one, so he said that it's unlikely that there isn't one, so maybe people wouldn't pick up on it. But clearly, two negations make a positive. All right, so a couple of other connecting words. And, or, and then if then. If then is considered one connective. It's called the conditional. We'll talk about it towards the end today. But we have to think of both of these words as one connective. They go together. Okay? So, and. I won the game, and it was fun. Or. I won the game, or it was fun. And then if then would be if I won the game, then it was fun. So, I won the game is one statement. It was fun is a second statement, and putting them together with a connective and or if then, that makes a new proposition, creates a new one. And the truth value of this new proposition depends on the truth value of these individual ones. And so that's what we're going to have to walk through and talk about. How do we determine this? So let's take a look at and statements. And is called a conjunction. Now that's a logical terminology. That's not English grammar. Okay, where in English grammar you have a lot of conjunctions. And is the conjunction connective. And so the only time that and is a true statement is if both P and Q are true. Think about it. You can get a college scholarship if you have a high GPA and a good ACT or SAT score, right? You need both, right? And kind of implies both. And so the only way to get a scholarship is if you got really good grades and got a high ACT, SAT score, then I get the scholarship. Any other combination, true and false, yes, I had good grades, but my SAT wasn't so great, no scholarship. My grades weren't very good. I had a high SAT score, doesn't matter, no scholarship, right? And then if I had neither, well, sorry, you don't get the scholarship, right? So if that is the determining factor for scholarship, if it's an and scenario, then you need to get both of them in order to be true, all right? So as an example, the capital of France is Paris and Antarctica is cold. Capital of France is Paris and the capital of America is Madrid. These are two different sentences, both created by using and. The proposition A contains these two pieces. Is the capital of France Paris? Yes. Is Antarctica cold? Never been there, but I've heard it is, yes. So true and true, this first statement is a true statement. However, for part B, the capital of France is Paris, that's true, but the capital of America is not Madrid, right? It's Washington, D.C. And so true and false, even though one of them's true, the other one's not, so the entire statement is false. It only takes one part to make it false, okay? Or can be thought of in two different ways, inclusive or exclusive. For us, we have to assume or is inclusive unless we're told otherwise. Now, sometimes it doesn't matter, right? What does inclusive mean? Either or both. Exclusive means one or the other, but not both. So if I say today is Monday or today is Wednesday, obviously it can't be inclusive because you can't have both of those at the same time, okay? But in general, when we say or in this class, in this scenario, it means inclusive. In other words, one or the other or both will make it true, okay? So in other words, if you have both P and Q are true, then or is true. If one of them are true, then or is true. The only time or is false is when everybody's false. So the only time and is true is when everybody's true. The only time that or is false is when everybody's false. Or is known as a disjunction because it's looking at one or the other. Okay, and so if you go back to the scenario that we talked about with the scholarship, if now they say you have to have a high GPA or a high SAT score, well, here you have both. And so you get the scholarship. Here you only have high grades. Your SAT wasn't that good, but that's okay. They give you the scholarship because it's one or the other. Here your grades weren't so good, but you had a high SAT or ACT score, so they give you the scholarship. The only time you miss out would be as if you had neither of those. Okay? And that's the way that OR works. As an example, airplanes can fly or cows can read. Is that a true statement? Well, the way we look at it, again, the or separates these two smaller statements. What do you know about airplanes can fly? That's true. What do you know about cows can read? I believe that to be false. However, the entire statement is an or statement, which means I just need one or the other to be true for the whole thing to be true, and so the whole thing is true. And that's correct. If-then statements, the conditionals. These guys are a little bit different, and we'll spend some extra time on them in class. The way that if-then works is this. I'm going to divide this in half. Okay? If we're looking at if P then Q, if P then Q, there's an order to this. When you're looking at and or, there's no order. Right? It doesn't matter. One or the other, doesn't matter. But here, there's an order to it. P happens first, then Q happens later. Okay? So what's happening is, here this says that the hypothesis, the first part, the if part, was true. Then the second part also was true. So is if then a true statement? If P then Q. Well, you did P, Q happened. Yes, of course it's true. You proved it. Here, if P is true and Q is false, then what happened? I did what you told me. I did the if part. If P, I did it. But Q didn't happen. So the statement if P then Q is false. Because I tried the first part and the second part didn't happen. If you study for the exam, then you will get an A. Well, if I studied for the exam and I got an A, then that statement must be true. But if I studied for the exam and got a C, well, then Q was false, and so the whole thing is false because I did what you told me to do, but it didn't work. Now, here's the questionable part for students. What if P doesn't happen? If you study for the exam, then you will get an A, and I didn't bother to study. I was busy, I had to work, I had my kids, I got sick, whatever. I didn't study, so P is false. Well, it doesn't matter if you got an A or you didn't get an A. It doesn't matter because you don't know what studying would have done for you. You have no way to judge whether or not studying would have gotten you a good grade, regardless of what grade you actually got. And so we have to assume the statement to be true. Innocent till proven guilty is the best way I know to describe it. If you can't prove me wrong by doing the first part, then you can't say I'm wrong until you try it. Okay? Remember, a logical statement has to be either true or false. Got to pick one. And so we pick that it is true. And there's other reasons for that, but we're not going to get into it too much. Okay? So, consider this statement. If it is raining, then am I wet? Is that a true statement? Well, we'll let P be it is raining, Q be I am wet. If P is true, it is raining. If Q is true, then I am wet. So is the statement, if it is raining, then I am wet, true? Apparently so, because it's raining, I'm wet, it must be true. And in the second row, this true means that it is raining still, but I'm not wet. I don't know how. I brought an umbrella, I stayed inside, I don't know, whatever. But obviously, if it is raining, then I am wet is not a true statement because I'm not wet. However, if it's not raining out, if it's sunny, okay, if it's not raining, it's a little bit cloudy, but it's not raining, that's a P is false. then it doesn't matter whether I am wet for some reason. Maybe I perspire a lot. Maybe I fell into a pool. Who knows? But it doesn't matter whether I'm wet or I'm not wet. It doesn't matter. You can't tell me if the rain will make me wet. And since you can't prove me wrong, you have to assume that it's true. And so therefore, the statement, if it is raining, then I am wet, is automatically true if it's not raining. Okay? Now, the conditional has lots of interesting pieces. There's lots of other ways to say if P then Q. Q if P, we can say that in English. P will lead the Q. P implies Q. P is sufficient for Q. Q whenever P. Q is necessary for P. All these are different ways of saying in English if P then Q, but there's only one way to create a truth table for if P then Q, no matter how you say it. Okay? So, these are in the textbook. We're not going to worry too much about the converse, the inverse, and the contrapositive, as this is a very basic logic intro course. But that's the deal. So we're going to work some problems together in class and try to get you some practice on that. But it's kind of a lot of memorization. So go back through the video and watch it again if you need to check out what's going on and to make sure you know the truth tables for the negation, for and, for or, and for if then. And we'll see you later. Thanks.